Hey everyone, welcome back to my series on building your own decentralized applications on Ethereum using the Embark framework. Today we're going to start our new project, and this is the second video in the series. So if you missed the first video where I explained how to install and how to set everything up, check that out. Link will be in the description. Link will be somewhere in this video. Go check out my channel. Don't forget to like and subscribe, and you'll be able to find it there. But today we're going to start our new Embark project. And we're going to write our first lines of Solidity code, which is a programming language used to write smart contracts. And then we're also going to write unit tests to make sure that that code is running perfectly. You know, with smart contracts, once you deploy them on the Ethereum blockchain, you don't get any do-overs. So if your smart contract gets hacked, it's going to be a big problem. So we want to make sure that we have our unit tests so that our programs, our smart contracts are as bug-proof as possible. So what are we going to be building today? Today we're going to build a censorship-proof decentralized message board on the Ethereum blockchain. You know, with all of the talk right now about censorship on social media and people getting banned and people being shadow banned, and what does shadow banning mean? And does Alex Jones get to use Spotify? You know, it's clear that these institutions like Facebook and Twitter and Instagram are really starting to show their age. And Ethereum, and it's no coincidence that people sometimes call Ethereum Web 3, in fact, the JavaScript framework that's used to power your interactions with the Ethereum blockchain in your browser is called Web3.js. Web 3 is really poised to dethrone Web 2.0 at this point. And with Web 3, you can do all kinds of great stuff to make sure that you never, when your application goes live, it doesn't change for the worse, right? Twitter, Instagram, all these services are just constantly changing for the worse. You get more ads, you get less features, it's more annoying, and honestly, we're all just sick of it. So today I'm going to show you how you can start building your own alternative to these sites, starting with our project, a decentralized message board. Let's check it out. All right, so the first thing that we're going to want to do is create our new Embark project. And if you missed, like I said before, if you missed the first video, just go check that out. Make sure you know how to get Embark installed, get all that done, then come back here and we'll get started. So if you watched that last video, the first thing we need to do is make sure that we're using the correct version of Node. And so what I'm going to do is source my bash configuration, so that we've got all our paths set up, we've got NVM ready to go, and then we're going to use Node. So do NVM use Node. That will make sure that we're using Node 10.7.0, which is what we'll want to use for this project to make sure that Embark is working fine. All right, so the next thing we're going to do is we're going to create a new Embark project, saying Embark new. And we'll call our project Ethboard. Why not? All right, so we've got our app ready at Ethboard. We'll go ahead and get in there. And as we can see, we've got all of these files set up and ready to go. So now what I'm going to do is I'm going to go into the Atom text editor. And if you're not familiar with Atom, it's an absolutely great text editor used by developers. It's got all this great plugin support. We're going to make use of some of those plugins today. So first I'm just going to go ahead and add my project folder that we just created to Atom. Let's see if I can find it. Whoops, close enough. We'll go into Ethboard and we'll go ahead and start creating our Solidity contract. So we'll go into contracts and we'll see here that there's nothing there. So we'll go ahead and create a new file. I guess we probably didn't need to do that. And the first thing that we're going to want to do is declare which version of Solidity we're using. So you'll see that at the top of pretty much every Solidity smart contract is a statement just defining what version of Solidity this contract is meant for. And we do that with this keyword called pragma. Whoops. Pragma Solidity. Then we do a little caret, 0.4.23. And we'll define our contract here using the contract keyword. We'll call it message board. And right now I'm just going to go ahead and save this file. Let me get the full thing here. We'll save it in our contracts directory, and we'll call it message.sol. SOL is the file extension for Solidity. All right, so now that we've done that, great. So what I have installed is some Solidity syntax highlighting. And syntax highlighting, if you're not aware, it's just changes some of the colors of the keywords and the different statements that you're making, the different portions of statements, so that it's just easier to program with. All right, so the first thing that we're going to create is, what is a message board actually made of? Well, it's a list of all these different messages. So we'll use the data type string, which holds an arbitrary amount of text information, and then we'll use an array or a list of strings to hold our messages. And then we'll use the keyword public to make sure that the information within this variable, this list of strings, is publicly accessible, because we want anyone to be able to read it, right? All right, so now that we have our list of messages, we have to add a function that allows you to create a new message. Now, even though the messages variable here is public, defined with the public keyword, all that does is create what's called a getter. It allows you to read or get the information stored within that variable. It doesn't allow you to set or write to that variable. So we have to make our own function that allows us to add a new message. So we'll go ahead and do that. We'll use the keyword function to declare that we are adding a function to this contract, and we'll call it write message. And the argument, the data that this function will take in, will be a string, and we'll call it message. And we'll use the public keyword here to define that this function will be publicly accessible, and anyone will be able to call this function. And all we'll do here is we'll take our messages variable that stores every message for our message board, and we'll use the function push, which adds a new item to the end of the list, and we'll push the message onto that list. And that'll pretty much be it for our contract for right now. It's very simple, but before we go any further, we're going to want to make sure that we can test this function in this contract. I'm going to show you two ways to do that. First, we're going to do a manual test, and then secondly, we're going to write some automated unit tests, which is a separate program, a separate piece of code that runs your program, runs your smart contract, calls the function, and then makes sure that the data returned by the functions is exactly what you expect it to be. So first we're going to test it manually, like I said, and this is one of the reasons that I'm using Atom today, is because there's some great plugins for Atom for Solidity and smart contract developers. So first, let me go ahead and save this, and then what we'll do is I'm going to show you, as you can see here, we've got this thing called Ethereum that is generating all these error messages and such. And I'm going to show you how to set that up and get it installed. So we'll go to our preferences in Atom, and we'll go to packages. And as we can see here, I've got a couple different packages set up. First of all, I got Vim Mode Plus, which allows you to use kind of keyboard shortcuts like the Linux text editor Vim. Also got Language Solidity, and that's what's giving me my syntax highlighting, as I mentioned before, to help me more easily just program the smart contracts. And then the one I want to talk about here is called Ethereum. And to install this, you just go over here to install, go ahead and search Ethereum, and then it'll come up, and then you can go ahead and click install, and it will take a little while to install. So once you've done that, we'll go back to our packages list here, and we'll go into the settings for Ethereum, because we're going to want to configure our blockchain information. And so what I've done here is I set it up to 127.0.0.1, port 7545, and that's my local machine, and 7545 is the default port that we'll use for this other program that's put out by the people who make Truffle, which I believe is Consensus, and that's called Ganache, or Ganache, or whatever, you know, the chocolate thing. And what that does is it gives you this great interface to run an Ethereum test blockchain just on your local computer. It makes setting stuff up super easy. So here we can see our RPC server is 127.0.0.17545. That's the information we've got here in our settings for our Ethereum RPC endpoint. And now that we've got this all set up, we should be good to go. All right, so we'll go back into our Solidity file, and we're going to bring up the Ethereum interface with the keyboard shortcut. Let me make sure. Key binding, Control-Alt-E. All right, so we'll go ahead, we'll hit Control-Alt-E, and we've got the Ethereum IDE here, and we can see our message.sol Solidity file, and we'll go ahead and hit compile. Error, no Coinbase selected. What is wrong with that? I think it's actually already compiled. One of the settings in Ethereum is to automatically compile your smart contracts as you save them. So we'll just go ahead and click deploy to blockchain. No? Do I have to put a 0 in here? No? No Coinbase selected? What's wrong here? Yellow node. Oh, so it didn't recognize that I have Ganache running, I think. So what we'll have to do here, you try restarting Atom now that Ganache is running. Whoops. All right, so I've got Atom restarted. Let's try this again. Control-E. Okay, good. So now we can see it's recognized our list of addresses, which are the same here in the Ganache run testnet blockchain, not testnet, excuse me, local test blockchain. No compile contract, so we'll go ahead and hit compile. Oops. Okay, great. So we've got it here, and now we're going to go ahead and deploy it to our local test blockchain, and now it's been deployed. Fantastic. So now we can get to the manual testing. First, we're going to call our write message function. All right, hello YouTube. Or if you're watching this on DTube, hello DTube. And I'll go ahead and hit enter, and that will call the contract. And if we go over here into Ganache, we can see that the current block is now 2. We can even take a look at the various blocks. We can see here our contract was created. And if we go to the second block, we can see our contract was called. And we got all this cool information about the gas used and the addresses involved and all that great stuff, which is really good for debugging. All right, so we've written our message, hello YouTube. And now we're going to get back that same message. And the way we do that is we've got this getter function here, messages, that allows us to read the messages that we've written to the blockchain. And to do that, we see it takes a uint256, which is a number. And basically what it's asking is which number message do you want to get? Because it's not going to give us, this is kind of a quirk about Solidity, when you have a getter for a public list, of strings or whatever, it's going to ask you for the index, which number message or which number piece of data you want to read back. And we'll put in 0. Now, if you're unfamiliar with this, 0 is the first element in any list. So we'll go ahead and hit enter, and we can see here our contract output is hello YouTube. Okay, let's try writing another message. Hello DTube. All right, we've called that contract. And now let's read the first message. 0 is hello YouTube. I'll go ahead and close some of these. And then our second message, which is at index 1, hello DTube. Fantastic. So it seems like it's working, right? But how can we be really sure that it's working? And how can we save ourselves time and not have to do this manual test to feel confident? And on top of that, as we change the code, maybe we'll accidentally break something that we've already written. And we don't want to have to go through this whole hello YouTube, hello DTube, message 0, message 1 every time to make sure that everything is still working. Because like I said before, bugs are a big deal in Solidity, and there are no do-overs once it gets deployed onto the blockchain. So what we're going to do is create a new file in the test folder that is automatically created. Actually, we'll just go into the one that's automatically made and edit that one. That'll be a little bit easier. When you create a new project in Embark, it creates this kind of example boilerplate test file that's all commented out. We're going to go ahead and remove these comment statements and write our actual test code. All right, so first things first, get rid of some of this boilerplate, and the first line here, we're going to declare where our contract is stored. And so we'll say const message board, and we'll point it at our message board contract. Then we'll configure that contract. So what this config command is doing the automatic deployment of the contract onto your test blockchain. And we don't have to define any arguments, just creates the message board. And then here, we're going to actually go ahead and define the test. So the contract that we're testing is called message board. And we'll leave this .timeout 0. Maybe we'll mention that another time, not important, just leave that there. And we'll get to the actual test here. So this is a function called it, and it's part of, I believe, the Jasmine test framework that's automatically included when you create an Embark project. And what it is saying is you're going to define what it, in this case our contract, should do. So we'll say it writes a message. Not messages, just a message. And here's from the example new project. You can check that out yourself at some point. We'll just get rid of that. And we'll go ahead. And the first thing we're going to do is we're going to await. And this is kind of a newer feature of JavaScript. This whole async await, which lets you do what's called asynchronous programming. I'm not going to get into that right now, but we're just going to await the result of a function call that we're going to make to our message board contract. And to call those functions, first we have to go into what's called the methods of the contract. And within that data structure, we'll live our function that we wrote in Solidity called write message. And we're going to write our test message here, testing, writing our message. And then to actually send that transaction and do that contract call, we have to call the function send. And let's make sure that we can see that our contract was deployed correctly. And we can get into some of the inner workings of what this message board object is in our test framework. And then what we're going to do is we're going to let the results of another function call, which is going to be our test result. We're going to await another method, which is going to be our messages function. So just like we did before when we did it manually, where we called write message, and then we used our messages function to see what came back out, we're going to do that automatically in this test. And we're going to pass that 0 because we're going to want that first message, and we're going to call that function. And then to actually make the test work, to compare what we expect to happen with what actually happened, we use this function called assert, which asserts that two things are equal, or in this case, that's what we're going to be doing. There's a bunch of different ways that you compare what you expect to see and what you actually see. So you can check that out. They're all different comparisons, greater than, less than, all kinds of different stuff. We're going to make sure that it's equal, and we're going to make sure our result is equal to our test message, which is testing writing our message. All right, and then we don't need this, so we're going to delete it and get rid of that, which is the initial comment block that was there, commenting out this entire file. All right, so we'll go ahead and we'll save that. And now we're actually going to want to run this test. So what we're going to do is we're going to go back into our console. And so we're here in our ethboard project folder, project directory that we created with Embark new. And we're going to just call Embark test. And that's going to run the test that we just created. So let's see what happens. First, compiles the contract. And we're waiting, we're waiting, we're waiting. Okay, great. Okay, fantastic. So if we look here at the end, it says all tests passed, one passing, and the name of the test was writes a message. And then we've got all this information here from that console.log statement, which writes out information just to your console here. So we can see what the contents of that message board contract are, and we're just going to go through this really quickly. We've got some information about, I think, our blockchain provider here, blah, blah, blah. We don't need to get into that stuff. Here's some other boilerplate code that's put in here for data conversion, things like that. And then we actually get down here into our contract data. So here's our contract data. Here's the, I guess, the address it was sent from. Here's the gas that it cost when it was deployed. And here's our methods that we can call in this contract. We've got our messages getter, and we've got our write message setter, which allows us to add a message to the list of messages. And then here we've got the address, the address of the contract. So what have we done in this video? First, we wrote our very first Solidity smart contract. We tested it manually using the Ethereum plugin for the Atom text editor. And then we wrote automated tests to automate what we did in our manual process to make sure that our smart contract is working perfectly. So in the next video in this series, we're going to start building the web application so that you can view this information in your web browser and see the messages come in and write the messages all within your web browser. And that's how users would interact with your web app through using a plugin like MetaMask or one of the various Ethereum browsers that are out there. And in the following videos, we're going to add all kinds of functionality to this application, and we're going to build it out so that you can post messages, so that you can add your name to your messages, so that you can save on gas costs by writing all of the data to IPFS, which is the Interplanetary File System, which is a really cool decentralized file storage system. We're also going to save on gas costs even more. I'm going to show you this really cool technique called stateless contracts that save a ton on gas and that you're going to want to do for any kind of decentralized application on Ethereum, because as we all know with what happened with CryptoKitties, it can be really easy to clog up the Ethereum blockchain. And from there, like I said, we're going to add all kinds of cool features, and we're going to build basically a really cool censorship-proof message board that you can deploy on your own, and you can get people to come and post on your message board, and the information will be saved forever, and no one will be ever able to censor it. So stay tuned to this channel, and like and subscribe if you want to see the next videos in this series. I'm going to be doing all kinds of Ethereum development training videos, all kinds of cryptocurrency trading advice, analysis of all these different cryptocurrencies and the blockchains from a technical perspective, news perspective, all that good stuff. So please give me that like and subscribe, and stay tuned for more videos, and I'll see you next time. Alright everyone, thanks for watching. If you found this video useful, please give me a like and a subscribe. That will help other people like you to be able to find this video and get the information they need. Once again, thanks for watching, and I'll see you next time.